In this video we are going to discuss about the types of ADC. So on completion of this topic, students will be able to understand the basic terminology and definitions of electrical and electronics engineering in analog to digital converter. So here we can see about the general purpose regulator. Before that we can see about the key features of this analog to digital converter. So while understanding this signals, that is uh, understanding the signals and the higher possible frequencies, we can find out the accurate measurements in the analog to digital converter. So this analog to digital converters are four types. First one is successive approximation analog to digital converter, delta sigma, dual slope, and pipelined analog digital to converter. So this converter mainly it is used to change the analog signal to digital, and also this converter is one kind of the integrated circuit that converts the signal direction from continuous form to digital form. So mainly which type of analog to digital converter is best means when we want to find the accuracy from more sampling bits, or if we need to find out the highest effective number of bits, sigma delta ADCs are usually the best choice, especially for low noise precision applications. So while comparing what is faster means, this flash ADC is the fastest type available, so that it can be used in the comparators, one per voltage step and the string space resistors. So this types of ADC, which is mainly unregulated DC supply voltage and adjustable regulated output, maximum load current, and additional transistor using here. So it is mainly used for 8 analog to digital converter, and this analog to digital converter can be used to convert the analog signals such as voltage to the digital form, so that can be read and it can be processed by the microprocessor. So here you can see the other four types, that is positive or negative supply, internal power dissipation, built-in short circuit protection, very low temperature drift, and high ripple rejection. So mainly why we are using this power dissipated converters, that is it can be divided into three different types. One is grid farming, grid feeding, and grid supporting. So mainly these are divided for two current source and voltage source based grid supporting converters. So these types of converters are mainly used for converting this input voltage and the output voltage when there is a fall in the voltages, and also this can be used when there is a change in the frequency. So you can see the functional block of this IC723 here. So this consists of the temperature compensator, voltage reference amplifier, error amplifier, and the feedback can be sent to the sent back to the input. And you can find the types of ADC in the temperature compensator, Zener diode, constant current source, voltage reference amplifier as shown in the diagram. And in the case of this error amplifier is a high gain differential amplifier which is having two inputs. One is inverting input and another one is non-inverting input. So inverting input we can be designed in the form of minus, and non-inverting it is designed in the form of plus. So this non-inverting terminal is connected to the internally generated reference voltage, and the inverting terminal is connected to the full regulated output voltage. And in the case of the serial process transistor, this is driven by the error amplifier, which is acting as a variable resistor, and also it regulates the output voltage. So mainly it is connected to the unregulated power supply. From that it is given to the circuitry for limiting the current. So this senses how much amount of current should be needed. So after sensing, if Q2 is normally off, it off the transistor, it turns on when it exceeds the pre-limited limit. So low current is capable of supplying the low voltage when it is equal to 2 or 7 volts. So you can see the voltage load here, and the resistor differences between this can be denoted as V non-inverting equal to R2 divided by R1 plus R1 plus R2. And mainly we are using the successive approximation converter because this offers a good balance between the speed, resolution, and finally it can be used in a wide variety of the signals also. So possible questions on types of ADC. First one, typical conversion speed of ADC is A less than 1 microsecond, um, less than 100 microseconds, less than 500 microseconds, and greater than 1000. Thank you.